In today's lesson, we're going to change gears a little bit and we're going to learn about the law of combining volumes. And this actually introduces an important topic in chemistry that once we learn about it formally in our last unit, you're going to use whenever you're learning about chemistry. And basically that's stoichiometry. So a lot of the concepts of chemistry that we know, we actually learn first in gases because they react in simpler ways than solids or liquids do. And this is one of the places where we discovered the relationship between moles and volumes of a gas. So Gay-Lussac, he actually made several observations about gases, but he was testing basically hydrogen and oxygen to make water. And he discovered that there was set ratios or volumes that always reacted to form water. Now we understand now what that is in terms of writing a balanced equation and using moles, but they certainly didn't know that back then when it was first being discovered. So it says, for example, when combining oxygen and hydrogen to make water vapor, if you've got 1 volume of oxygen, you need 2 volumes of hydrogen to make 2 volumes of water vapor, no matter which of the gases was in excess. So basically what it says here is you need 2 volumes of hydrogen combining with 1 volume of water to make 2 volumes, 1 volume of oxygen to make 2 volumes of hydrogen. And so it didn't matter if I added 3 volumes of hydrogen, only 2 would be used up if I had 1 volume of oxygen. So this was intriguing, right? And this, you see this and you're thinking, well, that makes sense. It looks like a balanced chemical reaction, right? But this was new for them. So this led to the law of combining volumes, which says when measured, and this is important, at the same temperature and pressure, volumes of gaseous reactants and products, key word there, it's got to be a gas, of chemical reactions are always in simple ratios of whole numbers. So they will always react in certain fixed volumes. And we now know that those volumes relate to the coefficients in a balanced chemical reaction. Now, why is that? And it's basically, it came from the idea from Avogadro. He was intrigued with this, and this was also the time that Dalton presented his atomic theory. So remember the billiard ball model of the atom. And Avogadro introduced the idea of molecules. So particles of gases that contain 1 or more atoms bonded together. So his theory is this: equal volumes of gases at the same temperature and pressure contain equal numbers of molecules. So what does that mean? It means that it doesn't matter if it's oxygen gas or hydrogen gas or chlorine gas or methane gas. If it's at the same temperature and pressure and it's the same volume, it will have the same number of molecules in it. It doesn't matter what it is. They won't weigh the same, but they'll have the same number of particles. So our example here is going to be nitrogen plus oxygen, and that's going to make nitrogen monoxide gas. So I'm hoping that these boxes are pretty much the same. And what I'm going to do is I'm going to represent this volume is going to have 4 nitrogen molecules. And there's my 2 nitrogen atoms bonded together. Now, it's going to react with oxygen. And I'm going to make my oxygens just little red circles here instead, and they're going to be open like this. Now, if you think about it, right, here, what you would have, right, with this reaction then is when they bond together, so I get 1 nitrogen, and I'm just going to save a little bit of time, I'm just going to draw my nitrogens first, and then I'll come in and draw my oxygens. So basically, bonds are broken, new bonds are formed, and there's my nitrogen monoxide. And you can see that here I've got 4 molecules, here I've got 8, so my volume is doubled. And so I need that coefficient in here to show that if this is 1 volume, and I've got 1 volume of oxygen, then I'm going to produce 2 volumes of NO gas. Okay? All right, so this means that if we've got a balanced chemical equation, we know how much volume, as long as we know the volume of one, we can figure out the volume of the others if temperature and pressure stays the same. So take a look at this. I balance out this chemical reaction. So I need 3 and I need 2 to balance that out. So I know that 1 mole of nitrogen has to react with 3 moles of hydrogen to produce 2 moles of ammonia. But moles and volume are directly proportional. So that means that 1 volume of nitrogen reacts with 3 volumes of hydrogen to produce 2 volumes of ammonia. So if my volume is 50 mils, then I need 3 times that volume, 150 mils of hydrogen, to produce 100 mils of ammonia. And it's because they react in these set fixed ratios based on their molecules, the breaking and the making of new bonds. So the volume of a gas is directly proportional to the number of moles of a gas present. And that really is the idea behind Avogadro's theory. So moles or molecules is directly proportional to volume. So how does that help us out? How does that help us figure out questions dealing with gases? And like I said, this is going to be kind of your introduction to stoichiometry. So here's the other thing. How do you know to do this kind of reaction that I'm going to show you? Basically, up to this point, we've dealt with only one type of gas, and we've changed its temperature and its pressure. Here, I'm giving you information about one gas, and I want you to figure out information about a different gas in the reaction. So let's go through and see how these problems are solved. It says hydrogen and chlorine gas react to form hydrogen chloride gas, which when dissolved in water produces hydrochloric acid. How much hydrogen chloride is produced if 0.783 liters of hydrogen and chlorine gases react? So you can see that I've got more than one gas involved in this. And so what you need to do for step 1 is to write a balanced equation. So I've got hydrogen combining with chlorine gas, and it's producing hydrogen chloride gas. And again, please remember that this only works in gases. This doesn't work in liquids or solids. All right, so balance out the equation, and here it is. Now, the next thing that you do is underneath the appropriate substance, you write down the information that the question gives you. So I've got 7.783 liters of hydrogen and chlorine. So I've got 0.783 liters and 0.783 liters of chlorine. And they want to know how much hydrogen chloride is produced. All right. Now, I hope that you guys can tell me before doing any math that it would be twice the amount of either hydrogen or chlorine, right? Because I'm producing 2 moles of hydrogen chloride for every 1 mole of hydrogen or chlorine. But how do you show that? How do you show that reasoning? And that's what I'm going to show you next. So I've given you information for both hydrogen and chlorine. You pick one of them and you write down that number first. And this is where, again, this process I'm showing you of unit analysis, we're going to follow the same thing. So now what I need is a ratio. Okay, remember this is the same way of changing grams into moles, of changing pressure units. And what I want is I want hydrogen at the bottom, so it cancels out. And I want HCl at the top, because that's what I'm looking for. Now I have to write numbers here, and I'm going to write numbers from my equation. So basically, I know that for every 2 moles of hydrochloric acid that's made, I need 1 mole of hydrogen. So I'm taking those numbers right out of my balanced equation. Now, do you see that hydrogen cancels out? As does moles. And to get my liters of HCl, I multiply by 2. Now, I do need to remember significant digits. Remember the numbers in front, the coefficients in a balanced chemical reaction are exact numbers. So we don't worry about significant digits for those. You just go back to your question. It's 0.783, so 3 significant digits. So this is 1.57 liters. All right, let's do a few more examples. Example number 2 says oxygen reacts with ammonia to produce the following. All right, and I've given you a balanced chemical reaction. Now, it says how many moles of ammonia at STP are needed to produce 45 mils of NO2 at STP. So you can see that my temperature and pressure did not change, so I can use a ratio. I know I have 45 mils of NO2, and they want to know how many mils of ammonia are needed to produce this 45 mils of NO2. So I'm going to start with the number that I've been given and the substance that it is. I'm going to use a ratio, and I want NO2 at the bottom here. I want what I'm looking for at the top. Now I'm going to use my coefficients, which are really technically moles, and write them in. NO2 cancels out, moles cancels out. And so to solve this, it's 45 times 6 divided by 7. And this turns out to be 38.57 mils of ammonia. And rounded to the correct number of significant digits, it's 38.6 mils, not liters, of ammonia. All right? So do you see how, again, we're using our balanced chemical equation to find out information of a different substance when we've got information about a certain substance? And that's the whole idea of stoichiometry, and something that we do in chemistry all the time. It's going to be our last unit. We're going to end up the course with doing this for both solids, liquids, and gases. But for gases, we're just introducing this here as a means of this is where it began. So you have to know how to do these, we call mole ratios, is what we call them. We call them mole ratios, so you can see the relationship between one substance and another. All right, and our last example here says how much oxygen is needed to burn 200 mils of propane. So I'm burning propane, and I hope that you still remember that with combustion equations, your second reactant is always oxygen, and your products are carbon dioxide gas and oxygen gas. And to balance it out, we're going to use CHO. So here's 3 carbons, 4 oxygens to have a total of 8, and this gives me 6, 7, 8, 9, 10, so I need 5 there. So here is my balanced equation for the combustion of propane. Now, I have 200 mils of propane. What volume of oxygen do I need to burn 200 mils of propane? So I start with the number that the question gives me. I set up my ratio. I want propane at the bottom, and I want oxygen at the top. And then what I'm going to do is just write in my coefficients. And this turns out to be basically 1,000 mils which to the correct number of significant digits is going to be 1.00 times 10 to the 3 milliliters, or 1.00 liters of oxygen. Oops, that went flying. Okay, so that's how to do the law of combining volumes. You've basically been introduced to stoichiometry, which is particularly important. And remember that with this, you are given information for one substance and you're being asked to find information about the other. It's got to be in relationship to a balanced equation. So your first step is always to write down a balanced